curriculum. In this lesson, we will go one step further and look at describing property boundaries using a coordinate system, one based on ordered pairs, called Northings and Eastings, to locate a specific location on an established grid. This method is gaining in popularity, especially with the advent of GPS, Global Positioning System. GPS is being used more and more by surveyors who own the latest and most technically advanced equipment. The Universal Transverse Mercator Coordinate System came into existence after World War II, when all the nations in NATO agreed that a standard global coordinate system was needed. This system would allow any place on the Earth to be described using two coordinates, an east coordinate to be known as an easting, and a north coordinate, a northing, from an established origin. In its final form, the UTM uses 60 numbered zones, each 6 degrees of longitude wide, and from 80 degrees south latitude to 84 degrees north latitude. The continental United States contains zones 10 through 19. The origin for each zone in the Universal Mercator System, when describing the northern part of the hemisphere anyway, is located on the equator, exactly 500 meters west of the zone's central meridian, to ensure that all the coordinates in the zone are positive. The UTM system is accurate to 1 in 2,500, which is really not very accurate at all. The state plane coordinate system made its appearance in the United States around the 1930s, when the U.S. Coast Guard, in conjunction with the Geodetic Survey and the state of North Carolina, produced the North Carolina Coordinate System. In less than a year, this system was copied into the remaining 49 states. Like the UTM system, the state plane system uses zones, but not those defined by latitude and longitude, but rather by state borders. The state plane coordinate system is more accurate than the UTM system, 1 to 10,000 units of measure, primarily due to the smaller size of each zone. As you can see, no zones span more than one state, but some states are so large they contain more than one zone. This gives us 120 zones in total. The origin for each zone is established by each state. Generally, the origin is 2 million feet west of the zone's central meridian and some distance south of the zone's southernmost point. There's no standard for the southern distance. Each zone is uniquely different. It might be interesting to have your students do some research and find out where the origin for your zone is. As with the UTM system, the northing is the word used to describe the north coordinate, and the easting the term for the east coordinate. To fully understand how to use northings and eastings to define specific locations, we need to define two important terms: departure and latitude. Departure is the distance in the east-west direction, what we know as the x direction of a grid system, while latitude is the distance in the north-south direction, what we know as the y direction. Departure. The sine of an angle beta is equal to the opposite side, which we have called the departure, divided by the hypotenuse, or the distance. Therefore, the departure is equal to the sine of beta times the distance between points 1 and 2. Similarly, the cosine of an angle is equal to the adjacent side, the latitude, divided by the hypotenuse, or the distance. Solving for the latitude tells us that the latitude is equal to the cosine of beta times the distance between those same 2 points. Now if we look at the triangle from a Metz and bounds perspective, we can see that beta is the bearing angle, in our example, north 48 degrees east, and the distance is the number of feet, 200. Putting it all together, before we move on to actually finding Northings and Eastings for any set of Metz and bounds descriptions, let's take 1 minute to calculate the latitude and departure values for the bearing of north 48 degrees east, 200 feet. The latitude is equal to the cosine of the bearing angle times the length of the property line. The cosine of 48 degrees times 200 feet is 133.826 feet. The departure is equal to the sine of the bearing angle times the length of the property line. The sine of 48 degrees times 200 feet is approximately 148.629 feet. The bearing angle, as well as the latitude and departure values we just found, will help us to determine the northing and easting coordinates. The general rule of thumb is, if the subsequent bearing states north, then the latitude is added to the previous northing. If the bearing states south, it is subtracted from the northing. In like manner, if the bearing states east, the departure is added to the previous easting and subtracted if the bearing states west. To help make sense of it all, let's just look at an example. The Metz and bounds property description has been placed in a spreadsheet. We are going to assume that the property description begins from an iron pipe in the northeast corner of the property, thence south 73 degrees west, 249 feet, 1 inch. The latitude and departure of this first property line is determined mathematically. The latitude is equal to the cosine of 73 degrees times the length of the property line, 249.08 feet. Just in case you were wondering, 249 feet 1 inch was converted to its decimal equivalent by dividing the 1 inch by 12. The resulting latitude is 72 and 82/100ths feet, rounded to the nearest hundredth. The departure is equal to the sine of 73 degrees times 249 and 8/100ths feet. This gives us a departure of 238 and 20/100ths feet for the first property line. In order to continue, the iron pipe needs to have an established northing and easting. Since we are unsure of where this property is located and whether we are using the UTM system or the SPCS system, for purposes of this example, we are going to call the northing 1,000 feet and the easting 1,000 feet. This might be something that you might have your students do for their lake property design. We have computed the latitude to be 72 and 82/100ths feet. Remember that the latitude is the length in the y direction, north and south. The benchmark's northing, the iron pipe, is 1,000 feet. The bearing states south. Therefore, we will subtract the 72 and 82/100ths feet from the known northing. This means that the northing at the end of the first property line is 927 and 18/100ths feet. We calculated the departure for the first property line to be 238 and 20/100ths feet. We established that the benchmark's easting was 1,000 feet. The bearing states west, so we will subtract the 238 and 20/100ths feet from the 1,000 feet, yielding an easting of 761 and 80/100ths feet at the end of the first property line. This process continues for each of the other property boundaries. Are you ready to look at the second property line and repeat this process?